This is Mark Sherburne from Juniper Networks, Global Solutions and Business Transformation Team. Today I'm going to be presenting the distributed data centers within Juniper Networks mobile cloud architecture. And this was presented at Mobile World Congress in 2017, and please enjoy the opportunity to have a look at what Juniper has. What I'm going to talk about is the challenges and the trends, discuss use cases and different solutions, as well as the products and services that Juniper offers to create the mobile distributed architecture to be able to really bring the cloud out into the network. That'll be the theme of what my session will be about here. And we'll talk about the proof points that we have out there and the actual mobile cloud architecture itself. So the challenge is we want to monetize the assets that the network brings for service providers, and we really see a very strong requirement to move the cloud computing and the trends that we see in the industry out closer to the edge of the network. We need the high bandwidth. We need the quick latency. We need computing to be pushed out so that we can generate revenue within the service providers, just like is being generated out in the cloud providers today. There's going to be each type of connectivity and each type of access that subscribers or users or machines need within the network. We'll talk about, but they can be run over the top into cloud providers, or they can be run closer. And I'm going to talk about running them closer. And what we want to do is to be able to create the same types of service offerings that are offered in the cloud, but push it down toward the edge of the network where it's applicable. Some of the trends, the huge amounts of data we're going to see. For the Internet of Things, or what I like to call the network of things, because it really doesn't need to be on the Internet, it needs to be on a network. And we're going to be collecting all kinds of information. And instead of going up to a cloud in the data center, we're going to see data that needs to go across in an east-west direction so that it can be processed at the edge of the network. Then only the important information needs to be archived in a bigger data center. But the more and more things that are connected to the networks, the more and more data we're going to have. And for all of that data to go across the network, then we're going to have to process it in a cloud or in a data center, which are the clouds today. We're going to pull that out so that we can have lower latency and higher bandwidth, better availability, a much flatter topology than we probably see today. Virtualization is everywhere. So this trend of making bare metal servers and running applications on them has several years ago changed to virtualization. So we recognize that, and to be able to support that, I'm going to talk about what Juniper has to offer to be able to virtualize the network as well and extend the physical network to the virtual network. And we'll deal with virtual machines or containers. We can look at the underlay with our switching infrastructure and our routing infrastructure, and we'll want to lower the cost by having centralized controllers that can now look at the network more holistically and program the network versus individual configurations that had to happen on all the devices previously. And the cloud is everywhere. What we have today is the ability to take those virtual machines and scale them out to as much as you need instead of adding more and more and more hardware, but then scale it back in when you don't need as much. And on demand. If I want something, I want it now. I don't want to wait for 3 weeks to be able to get an order and get my what I've ordered back. So we have to automate that. It needs to be automated so we can scale out, scale in, ask for something on demand. The agility of that automation is going to allow for a multi-tenancy within these cloud environments so we can slice the network and then allow those slices to have the security that Juniper offers on top of the agility to be able to order those on-demand services or scale in and scale out that you need. So big data, virtualization, cloud, we want to pull that all together, and we want to help to create the networks of tomorrow and today and going into tomorrow to be able to handle all of those environments. So the different fabrics that I'm going to be talking about today, if we look on the left, we really have to start by looking at a micro data center to really think about what we're trying to do. So if we need to have what's known as virtual network functions, which are just VMs, running way at the customer site, we can do that on a single server. That single server may be Juniper's UCPE. It could be an x86 box. But what we have to think about here is to be able to have the compute that we need where we need it. So this would be at a branch office, at a customer site, in a radio access network. Many places throughout the network, where applicable, we want to be able to run the VMs so we can run it on Juniper hardware. As you get bigger, and if you're at the edge of your network or if you're in a data center, the one thing we don't want to do is we don't want to waste our links. So if we use multi-chassis lag, which is a way to aggregate, link aggregation is what it stands for, aggregate links together. If I'm coming off of a switch that is supplying connections to my servers, I want to use both links. So we use the multi-chassis lag to be able to allow all the links to be used, and we don't have wasted bandwidth and wasted utilization of our circuits that we have there or our network that we've built. Or as we go into a more cohesive type of data center, what we want to do is manage all of our entities as one. That's where the Ethernet fabrics come in. So we can do virtual chassis where all of these devices look as one, or Q fabric, which is for a generation of Juniper's fabric architecture, and our latest one is the Junos Fusion. So all of these will be a single management for all of the devices that are within the data center. And again, the data center can be a large data center or it can be a smaller distributed data center, but these architectures are applicable to all of them. And as we get really huge, all the cloud providers and everyone that's running the software as a service, web services companies, everyone's using IP fabrics. You can then do policy, and you can get all of the benefits of IP or TCP/IP features that we couldn't get in the switching technologies. So what we're doing is we're really looking from a distributed all the way at the edge into different ways to be able to support larger and larger and larger data centers. So Juniper's portfolio actually covers all of these. So from our NFX box down at that runs at the customer site, all the way up through our QFX series, our EX series for 1 gig ports, and our QFX 10,000, that's all 100 gig ports. So we have spine and leaf architectures where you have the spines, you have the leafs, and the products to be able to handle each one of those. They all run one Junos. So one operating system where we can take advantage of the programmability of Junos. And if we need to configure a NFX or if we need to configure a QFX 10,000, the same API calls and the same code to be able to do changes and monitor these devices can be used. And above that, we have Control Service Orchestration, Junos Network Director, and OpenClause as other software components to be able to do true automation as well as the orchestration and monitoring of services that we're turning up within these networks. And if we go through each one of these, we'll have the UCPE first, which is our NFX series, the NFX 250. What it is it's running a Linux kernel that has a processor, can run VMs on it with KVM. It supports DPDK and SRILV. It has 10 gig WAN ports and 1 gig LAN ports. It does full zero-touch provisioning, and you can do service chaining of your VNFs. So if you need to have a deep packet inspection and a firewall, instead of having multiple hardware devices, you simply run them as VMs on this device. And this is called our distributed cloud CPE. Third-party VNFs would also have to be run because Juniper doesn't make all of the network functions. Things like WAN optimization. We'd rely on partners that we have to be able to supply those virtual network functions. But Juniper does the service chaining to make sure that the data path goes through all the virtual network functions in the proper order, and the return path works the same way. And then we really need the centralized management. Just like I talked about the Junos Fusion when we talk about our fabric infrastructures within a larger data center, we want centralized management for all of our devices that are out there in the network. As we move into the MC lag, what we want to do here is we want to really take advantage of what looks like a single node to be able to be the spine, and those QFX 10,000s will now be able to take packets and have all of these links now available to be able to send traffic across, instead of having a spanning tree where you have to have certain links shut off and you're not taking advantage of all of your utilization on your links that you can. This is for really large layer 2 domains. As you see, we're going to move further and further away from the layer 2 domains just because of the abilities we have for policy and such for the IP routing. But this technology with the MC lag still covers, 13,000 10 gig ports. We really look at oversubscription on it, but you'd have to look at what your VMs are all requiring to be able to determine what your oversubscription would be. As we move to the fabric technology, the key here is what you'll see on all of the fabrics, including Junos Fusion, although it's not listed, is that it's a single management entity. So the key is that the masters or the spines, they will be a boss or the controlling component of each one of the leaf nodes within the fabric. So what you're doing from our network management of Junos Space Network Director, it's looking like one device that can go up to 128 leafs coming off of your spine. So it looks like one huge switch that each one of the ports coming off of the leafs going to your servers is controlled by the top level. And we can have a whole mix. We'll have EX switches down here and QFX switches at the leafs so that we can support 1 gig, 10 gig, or 40 gig. We can scale in QFabric up to 128 members, and they all have the open standards of programmability so that we can actually do more automation. If I want to test this entire fabric to see how many ports are up and what MAC addresses are on those ports for an inventory control, I can do that as a snap. Just a really quick test to automate, and I can do all of my checks and monitor my environment much, much easier on Junos than you can in any other vendor that's on the market today. When we go to IP fabrics, this again is what I had indicated we see in a lot of our huge hyperscale data centers. And the key to routing protocols is the equal cost multipath. So now if I'm talking an IP routing protocol from my leaf to my spine, and all of my spines know all about all of my leafs, just like MC lag, I can run traffic across multiple links with a equal cost methodology where I'm going to split that traffic by hashing the flow of packets that are coming from VMs running on servers, from bare metal servers, up through the network and either out the network or across to other VMs, servers that run within the same data center. We still look at a 3-to-1 oversubscription, but you can see we scale up to over 110,000 10 gig ports in fabrics like this. And we see data centers that are getting that huge, that are in production today and obviously just growing. So from what we've talked about so far, we talked about the micro data center as our UCPE, different scaling capabilities of the size of the data center, and it doesn't matter where they live. We still want to use the same architectures, and we want to have the single management as we talked about with the Q fabric, with our network director, with our Contrail service orchestration, to be able to manage any of these choices that you may have to be able to build your data center and your distributed data centers to be able to have one pane of glass to manage everything from. One thing we want to do once we get these network underlays built, which is the spine and leaf architecture, is to introduce an SDN controller that is Contrail networking. And Contrail networking, what it does is it takes the virtual environment, as you see up here in the cloud, and it makes that virtual environment a server-to-server stretch. So tunnels will go in between servers. So an example of the Purple VM being able to talk to a Purple VM is perfectly fine, even though they're on different servers. The Contrail networking component will allow that to be able to connect together seamlessly. Here in the little diagram that you see, we have a green and a blue. Well, those can never talk to each other without a policy that links them together. And when that policy links them together, there we can add services like firewalls to really truly have a secure network versus having each one of the hosts being prone to crosstalk in between networks. We don't have to do VLANs any longer. So that's the huge thing, that when you are looking at an SDN controller and a data center, once you have the infrastructure set up, you now just want your servers to talk to each other. And by putting the Contrail vRouter on the servers, that is now a entity that can do the network slicing and the multi-tenancy that's needed to support the environments that we're building today. To get out of the virtual environment, though, which is what we've created, we created our infrastructure, our underlay network with our switched fabrics. Then we attach those VMs that are multi-tenancy VMs with our Contrail networking. But to get to the physical world, we need to have our SDN gateway routers, what's known as our universal SDN gateways, to be able to do that. So if we need to get to the outside world, we're going to have our MX routers that communicate with each other across a wide area network or the internet and seamlessly connect you into any of the cloud providers. If the traffic is going to the internet, then we are simply a SDN gateway router on behalf of all the virtual environment, just to be the translation to get out to the world. And the key is that from our Contrail environment and our MX environment, we just talk normal standard routing protocols. So the physical network and the virtual network are now married together in a very seamless architecture that is easy to implement, scales, connects layer 2 networks, connects layer 3 networks, connects the external world, and it connects clouds together. All Juniper products, from the switching infrastructure through the virtual networking on the servers themselves, to the gateways, to the gateway data center interconnects that need to happen to be able to build a scalable distributed data center. Here's an example of what's possible. From the mobile world, we've always kind of left it separate, where the mobile world did its own thing, and many years ago, mobile networks were built on their own, and they were running as ships in the night versus our wireline. And what I want to demonstrate here is the ability to use the affirmed virtual EPC, and coming in from the RAN, we can identify specific employees for an enterprise. If those enterprise users are assigned to an APN or an IP address pool that has policy on it, then any traffic that needs to get to any of the enterprise, whether that's a site, whether that's headquarters, what we can do is we can use policy through our virtual SRX software and do IPsec tunnels for security to bring back the traffic from even the mobile subscribers into the enterprise, and the enterprises, either L2 or L3, to bring that traffic across the internet directly into the telco cloud or the service provider cloud, so that what we have is now mobile users, layer 2 connected facilities, layer 3 connected facilities to the internet or directly connected to the service provider, all managed as one enterprise. The mobile users don't have to put special VPN software on. When there's machine-to-machine communications, we can pick up the identity of the machine, we can assign them an APN, we can put them into the enterprise so that they can process what they have on the machine-to-machine communications. This is all possible now by distributing the data center out where the EPC is, create a virtual EPC. We have data centers that are distributed across the network, whether they're large, small, medium, it doesn't matter. We're going to use the same architectures that I showed you to be able to turn up virtual machines, to be able to scale out the spider and leaf architectures for the communications between all of these billions of endpoints that we're now going to see on the radio networks, on wireline networks, on Wi-Fi networks. We want to be agnostic of how we connect into the network, but use the same technologies. As an example, IPsec here or IPsec here. The same technologies, being agnostic of how the connections actually happen. And here's an example of being service aware within the radio access network. When we talk about the multi-access edge computing, what we need to do with a partner of ours that's Sakuna Networks is to be able to take the GTP traffic, and it's encapsulated. So somehow we need to de-encapsulate it. We want to make sure it's secure, so our security gateways, but the key is to be able to have local breakout as well as hosting of the multi-access edge computing infrastructure. So you may have offload processing such as DNS, potentially content delivery. A good example may be a download of a update on a phone. Have it here within a very short distance from where your actual consumer of that content is, no matter what the content is. And this is where breaking out the network or the data center, into a distributed fashion, you'll find benefits from that. And what are we looking for? We're looking to improve the user experience. And we can do that because it's local. It's very, very close to where the user is. This is going way back into a compute data center that may be hundreds, thousands of miles away. Let's do it really, really fast. There's going to be applications within this IoT world that must have that immediate communications. It must have very quick turnaround times on data. But you won't be able to store all your data out here. So we'll need processing and applications that do the processing of the data collected coming in, and then say to cloud services the information that's really required. So an example may be if I'm taking sensor readings constantly off of railroad tracks, as an example. If I'm taking in those readings all the time, they're always the same, I most certainly don't have to send them up and store them. I want something to process them and only send up if there's a change. You'll see that type of example all over in the IoT space as time goes on and new applications are developed, and making the world a better place with all of this information is what we're going to need. And then up in cloud computing centers, we're going to use that for all of our analytics data, where we're going to make choices and help to be able to utilize that data that's collected for the benefit of everyone. And we want to better use our network resources in this environment as well. Obviously, if we don't have to go into the core of the network, we're going to save the bandwidth in the core of the network. Why send useless traffic back there if you don't have to? That's the key there. I'm very much in favor of distributing this data center out to the edge, distributing all the compute as much as we can out to the edge, and the service provider networks are out there, are ready to receive this. And Juniper has the solutions with our partners to be able to supply those distributed data centers that are required in the network going forward. And we want to be able to monetize it. Obviously, we have to be able to look at the money we're spending to be able to create these distributed data centers. We need a way to be able to drive revenues, to be able to pay for them, and to be able to support them, and to be able to bring on new services as the customers are requesting that. Here's an example of how flexible it is. Here if we start off, we have a portal that a customer could utilize that's communicating with our Contrail Service Orchestration. The Contrail Service Orchestration is controlling not only the virtual network functions, or VMs, that are running within any of our distributed clouds, but it's also going to communicate with our SRX line of devices that lives out in the network, and other third-party devices that may live out in the network as well. And if it's just layer 2 and layer 3, this is what is typically out there today that customers have. Where it's going is you're going to see a trend of using over-the-top internet access, as well as those managed links that were there, to be able to split the traffic in what's known as software-defined wide area networks. And here I'm showing at this UCPE as a layer 3 device, but it's also running VMs. So if we need localized VMs that may be running our deep packet inspection, maybe virtual SRX that can interface with our Sky ATP platform to be able to do localized malware protection, and then firewall and NAT that needs to come off, along with policy that can track at layer 7 the applications that are being used and decide, just for normal traffic, I can take this over the top, but for all of my voice and other very important traffic, I want to keep it on a very secure and managed line on an MPLS network from a service provider, as an example. Once we get into the data center edge, what we want to do is we want to be able to supply other services that may run at the customer site. So these other services may be value-added services that are VMs for backup services, or other types of sophisticated protection or business applications that you may want to live within a private cloud, but they're accessible for your customers or your end sites to be able to traverse the network and instead of putting hardware in, we're going to use virtual network functions that run as software to be able to supply those. Again, here we're showing a customer building, but there's no reason that can't be the GI LAN side of the radio access network, or the virtual EPC, or the EPC that the mobile world would be accustomed to. And I did mention the SD-WAN, but we really want to think of it as Juniper is, we don't want to secure the network, we want to build secure networks. And building secure networks, what we want to do is put security everywhere. Put security at the local branches, or put security within the network. Here I show just a couple examples where we have our SRX series, and we have our distributed cloud CPE, or our UCPE for the NFX. All of the functionality to be able to make choices, where I talk about using the managed link or the MPLS circuit for, say, voice traffic with Skype and VPN access, or other types of very important traffic would go across the managed link. Maybe Office 365 could go right straight over the internet, but through a tunnel, so that you have a more defined path that you can secure, and other traffic that's just YouTube or general internet. So these could be all different links, and what you want to be able to do is decide which applications you want to be able to send out there. So with our virtual SRX, or SRX branch code that runs on our hardware or runs as a VM on the NFX series, the application's app secure feature set allows us to track and apply security at layer 7, be definitely application aware. So once we're aware, we can route on that traffic to be able to choose the links that we want to use. We're going to use centralized policy control as well as security and managed VPN services. So what you can do is, from your sites or from the radio access network coming across the GI LAN, you can make choices on what traffic you want to put where, all based on the application suite of app security in the virtual SRX or the SRX product line. And SkyATP and the Spotlight Secure services are a cloud-based service, but all of our SRX series, virtual SRX as well as physical SRX, can utilize these cloud services to really protect your network against malware and other threats beyond just the basic firewall security threats that we've used for years and years. And the whole portfolio that we have, I'm not showing the NFX here because I'm kind of sticking to the data center, but at the leaf, we're going to have multi-gigabit ports coming off of EXs. 10 gig and higher will be our QFX product lines. And if you need deep buffers, you can get that with specific series. The OCX is for the Open Compute platform, and that is a white box, but it is the same as our QFX. As we get into the spine, we really want to go with the QFX 10,000s that are all 100 gig downlinks, so that you can get massive scale to be able to get to those 10,000 plus ports that I'd mentioned earlier in the presentation. And at the data center edge or data center interconnect, again, the QFX 10,000, just like in the spine, our MX series routers or EX9200s would be what you use to ingress and egress out of the data center. And we'd always recommend to front end those with our SRX, larger SRX products, to be able to make sure we build security all the way through. And that you'll see in another presentation on our security products later. To do all of this, we want to supply the services that are really required to build these distributed data centers. And if we stick with the plan, build, and operate, what we have, we need to plan what we're doing. Always plan what you're doing. So assessment services and, the idea of designing and building what you want to meet your business requirements, do it up front. You'll have a lot less pain if you have a good plan going forward. Because without a good plan, it's really hard to build something that's going to work for you. And without something that's built to plan, to operate it is going to become a huge challenge. So our Juniper Professional Services works in the plan stage with assessment services, in the build stage with deployment services, and if you need to customize outside of our standard packages, we can customize any type of engagement, whether that's going to be to build out a distributed data center all the way to onboarding the customers to be able to help them all the way along their journey. So look for Juniper Professional Services to help any of the distributed data centers you're looking to design out today. And operation-wise, Juniper Care, Juniper Care Plus, and Juniper Optimum Care, these services are fantastic. Juniper is really proud of our services organization and what they bring to the table, and they really help us and our customers day to day. The education and training, that's for everybody. So Juniper Education and Juniper U are fantastic services to be able to get you up to speed while you're planning, during the build process, learn the details of these products, and even during your operations, let's keep up to speed on new products and new developments and new features. Let's utilize the training to be able to get us educated on what we have. So some of the proof points, we have tons of different references from our customers, but here's a couple that you can read and some awards that went out. The Saguna and Juniper win our recognition in the Mobile Edge Computing Congress is those are just examples of us working with someone else, Juniper building layer 2 and layer 3 networks, and we're very strong with customer references, and here's just a couple examples. As you saw, we have a broad portfolio from micro data centers to huge hyper cloud data centers. The key to low latency is going to be really important with things like self-driving car, remote healthcare, lots and lots of other examples where the low latency and have that compute at the edge are required to build the distributed data centers is extremely important, and we need to not lose sight of this. And it needs to be flexible from top of the rack to the end of the row. Data center switches, they're modular. They're the top of the line in the industry, and we really wanted to show that we have everything that you need to build the data centers from micro to massive. And it's investment protection. One of the other things about investment protection is Junos. When you do training for your employees, Junos is Junos is Junos. So you're going to save a lot on OpEx just running with Juniper products, and then the same switch can support multiple architectures. It could be run as a MC lag that then is transitioned into a Q Fabric or a Junos Fusion that could transition directly to an IP fabric. So all of those are still supported through the same infrastructure that you're purchasing, so you're protecting your investment moving forward. And all the features we have on our router are being incorporated into our data center switches, and I truly believe that there's going to be some day you may not find a whole lot of difference between router and switches in the industry that we have or that we know. So this was one of our 5 solutions, and it was called Distributed Data Centers. And from our mobile cloud architecture, the 5 solutions, well, I'll talk about it on the next slide, but specifically what I wanted to talk about here was the mobile edge computing or multi-access computing, multi-access edge computing, security gateway, or the S gateways and the P gateways, along with the security gateways, which are firewall and NAT and VPN types of services, the virtual infrastructure that we can build, and to distribute the data center, don't look at this picture as we want to have data centers everywhere, but I think we do. You can have them anywhere is really the key. If you want centralized, I showed you where you could have 10,000, 100,000 servers out there. If you want to have micro, where you have it at the site, I showed you our UCPE or our NFX platform. So from our NFX series all the way through our QFX, EX leaf switches to our 10,000 QFX 10,000 spine switches, our data center interconnect and universal SDN gateway MX series routers, Contrail networking to marry the virtual world with the physical world, and Contrail service orchestration as an overarching orchestrator for all of these network components. This is what we went through on this section of the mobile cloud architecture. And if we look at the other sections, you'd like to be interested in the automation of control and orchestration, security, disaggregation and virtualization, as well as integrated packet and optical and timing solutions, please see the other presentations that will be available at the site or at the Mobile World Congress if you are fortunate enough to be at that event. So we got key use cases for each one, best of breed of the partner ecosystem, and the life cycle and support. Each one of these solutions will have the same theme, so please pay attention to the consistency that Juniper has across all of our solutions. And I thank you for your time.